Chapter 11, Introduction to Vector. In this video, I would like to demonstrate some example and illustrate some special properties, or how can we make good use of vector to find the coordinate. Let's see the first example. Example 11.2. A, B, C are the vertices of the parallelogram. Find the coordinate of D. In S3, we have already discussed that how to make good use of the slope, the concept of the formula of the slope to find the coordinate point D. Or you can also write down the point D directly by using the property of parallelogram. But this video, I would like to introduce how can we make good use of vector to find the coordinate of point D. And I also want to introduce some special property of the vector. First of all, I want to emphasize that because this is parallelogram, the length of AB and then the direction of vector AB must be equal to vector DC. That means I know vector AB is equal to vector, remember DC is not CD, so I can find AB by using OB minus OA. So it's 1I plus 5J minus 3I minus 2J, which is equal to negative 2I and plus 3J. I know this vector is equal to this vector. So I can let OD is equal to AI plus BJ. How to find DC vector? DC is equal to OC minus OD. So it's negative 4I plus 6J minus AI minus BJ. I want to group all the like terms together. Negative 4 minus AI plus 6 minus BJ. Because these two vectors are equal, that means one of the characteristics is that the I coordinate and J coordinate must be equal to these two parts. So I can find the values of AB. I know negative 2 is equal to negative 4 minus A. So A is equal to negative 2. And then 3 is equal to 6 minus B. So B is equal to 3. Then the coordinate of point D is equal to negative 2 and 3. I don't want to go through for example 2. Maybe you can use this example to do it again. But you can also, it is not very difficult to check the answer by using some technique, the special technique. I know the answer must be 4 and 1. So you can check your answer. You can demonstrate the previous idea and then check your answer. Example 11.3. We have 2 points, P and Q, are on the coordinate plane. OR is equal to lambda minus 1 times OP plus lambda times OQ. Express R in terms of lambda, I, and J. Part A, OR. This is the given information. OR is equal to lambda minus 1 times OP. OP is equal to 4I minus 3J plus lambda times 2I minus J. So I want to group all the like term. That means related to I is 4 lambda minus 4 plus 2 lambda. And then how about J? J is plus negative 3 lambda plus 3 minus lambda. I take out j and group all the like term together. I know this is equal to 6 lambda minus 4 I, and then plus minus 4 lambda plus 3j. This is the result of part A. Okay, part B. If OR is parallel to 3i plus 4j, OR is parallel to 3i plus 4j. What is the meaning about parallel? Parallel, that means the direction of these two vectors are equal. Maybe you can use the previous some technique, for example, find the tangent theta. That means the direction of this vector, and then which is equal to the direction of this vector. I also want to tell you another concept. For example, if I have a vector 3i plus 4j, just like this one, okay, this is 3 and this is 4. What is the Melbourne parallel? That means OR, maybe longer, or in other directions. But I'm sure that the ratio of the I and j, the coefficient of I and j must be equal. So if two vectors are parallel, I can compare the ratio of these two vectors. So this is 24 lambda minus 16, and then negative 12 lambda plus 9. So 36 lambda, and then this is 25. Lambda is equal to 25 over 36. So, next page. Here are the conclusion of the previous two examples. If two vectors are equal, first of all, we need to know A must be equal to C, and then B must be equal to D. Remember, these two vectors must be non-zero vector. If two vectors are parallel, I know the ratio A over B must be equal to C over D. You may do follow-up exercise 3 and submit it through Google Classroom. I also want to demonstrate the last example, example 11.4. A, B are 2 points on the coordinate system, and O is the origin. P is the line segment. Do you remember this kind of example? We have 2 points, 4 and 7, and 1 and 1. P is a point on the line segment such that AP, this is A and this is P, AP to PB is equal to 2 to 1. We have already discussed how can we find the coordinate of point P by using, maybe we can let AB be the coordinate of point P. I know A is equal to 2 times the opposite one, 2 times 1 plus 1 times 4. 1 times the x-coordinate of point A, and then over the total ratio is equal to 3. And then B is equal to blah, blah, blah. But this today, I don't want to emphasize this method because we have another method to find AF by using vector. Okay, we can use one equation to find it directly. The concept is similar to this one, but we can use this to multiply the vector OB. That means I consider we have a vector OB. Remember, must be starting from the same point, and then 2 times OB plus 1 times OA is equal to over 3 is equal to OP. So I know OP is equal to 2 times I plus J, and then plus 1 times 4i plus 7j over 3. The total ratio is equal to 3 plus 1. So it's 2i plus 4i and then plus 2j plus 7j over 3 is equal to 6i plus 9j, that means 2i plus 3j. here is the conclusions. Okay, remember you need to submit the previous example, the follow exercise, and let's discuss during our lesson.